Hi guys, this is how we can do the week 5 lab using only Excel really quick. Alright, so I have my questions pasted in here. I got my data right here. Alright, so let's tackle it. How many participants do we have? That's pretty simple. We got 100. Cool. Alright, number 2. What is the distribution of majors in our data set? Alright, well, we're going to filter. Nope. What's the question again? What's the distribution of majors in our data set? Alright, so let's filter by major. And this guy is actually just called major. So let me filter. Alright, if we're just looking at major 1, how many is this? 23. It's really that simple. 2. How many? 19. Did I even do the first one right? 23, yep. Cool. Yeah, and that it all makes sense. What's our third major? How many do we have? We have 18. And our fourth major. No, I want just 4. How many do we have? 19. Cool. And if I look in here, I describe what each major is. Computer science, electrical engineering. Computer science, electrical engineering. Psychology, and then art. Alright. I kind of want to make a pie graph, pie chart, whatever you want to call it. See if I can do that in here. So let me just make this a nice little table. 18, psychology 18, art 19. I've never actually done this before, but let's see. I want a pie chart. That didn't work out. What if I just say pie chart? Oh, hey. Cool. Boom. Dunzo. Dunzo. Can I put... Can I directly label these things? I don't know. But this is good enough. If I wanted to get the percentage, well, I know my n is 100, and so I would just have to do 23 divided by 100, which equals 23%. Boom, it's pretty easy. So if I wanted to directly label these things, I could. But I won't. Alright, done. Alright, what's the gender distribution in our data set? Oh boy. Let's put all of those guys back. Let me add a filter to gender. Alright, gender 1. How many do we have? 50. Whew. What's 1? 50 females. That probably means 50 males. How did I misspell females? Okay. Do I have to make a chart from that? That's kind of dumb, but whatever. 50, 50. Insert a pie chart based off of that. Boom. Select data. I'm going to edit that. Okay. Okay. Exactly 50-50. Alright, which major has the highest IQ? Alright. Let me clear that filter. I'm going to go back to sorting by major. Alright, just one. IQ. Average 111. What exactly was it? 111.52. I'll just go to 2 decimal points. Okay. Just double check. 116.33. What was 2 electrical engineering? What's the third one? Psychology. And then art. I'm just looking at the third option. 110.59. $115.22. Oops, forgot about physics. Means I messed up the first one, but you get the idea. It is 109. Alright, can I just plot this? Hey. Alright, so everything's pretty close together. It's better if this range started. Can I format the axis? Just see how you can pretty much lie by zooming in right here. Since we're zoomed out all the way from 0 to 200, there's no real big differences between here. I mean, what's our range? We go from like 109 all the way up to 115. It's a range of like 4. That's not that big. Okay, do you think this trend would hold true if we collected more samples? Alright, so if I collected another 100 data points, if I did this same experiment again next year, do you think that it would still go in this order, right? So where, what is it, electrical engineering are just barely the highest, followed by physics, then CS, then art. No, all of these are pretty close together. I bet if we did this again, it's definitely possible that maybe CS was the highest or psychology was the highest. You know, I think this exact ranking of mean IQ by major just happened by chance. So I'm going to say, no, I don't think this trend would hold if we did the experiment again. Alright, who's taller on average, males or females? Great. So let's clear that filter. Let's add a filter for gender. One. I only want to see one. And what are we talking about? Height. What's our average height? 173. .11. And what is one? One is female. One day, guys. And what's my male height? Again, only males. 170.61. Real close together. Insert a, boom. Alright, so it looks like 173 versus 170. So what is that, like 3 centimeters difference? It's nothing, guys. Can I copy both of these things at the same time? Let's see what happens. Nope. Alright. What variable correlates the most with IQ? Alright. Let me take off all the filters. Take off all filters. Alright. So if you've never done a formula in Excel, this is how you would do it. If I wanted to get the, here's an example, if I wanted to get the average of this whole list, I mean, it's already down here, but just as an example, I can start typing average, and there's a bunch of options that come up. So I can say average, and then it's telling me what it needs. And I know that average, I need just to give it the range of all the numbers that I do. What am I doing? Well, I'm not doing anything right now. So if I wanted just the average of GPA, I'd type in average. Now it's waiting for the range, and I can just do this. And you see how it says J2, which the J, row 2, starting, and then colon, so going all the way to J101, which is all the way at the bottom. So that's the whole range. If I want to find the average of that range, I do that, I hit enter, and then boom, that's what it is. Cool. Now there's correlations, right? Correl, I'm going to do, cool. So that is my first array, and that is my second array. Does it do it? Ooh, it did it, and it even ignored those guys. Perfect, perfect. So that's the R between exam 1 and exam 2. Alright, now we kind of have to do this a lot. This is one place where having SPSS could be faster. We could do all of that stuff, but whatever. We're being stubborn and not using SPSS today. So what were we doing? What on earth were we trying to do? We are on number 7. So what variable correlates the most with IQ? Okay. Alright, so IQ is, let's make a bunch of these guys. So equals Correl between that, comma, and that. Close it. IQ and GPA. IQ, GPA. Let's do the same thing again. Equals Corel between oops, equals Corel. You can hit tab and it'll autocomplete. We did IQ and GPA. Now let's do IQ and weight. Oops. IQ, then comma, all of weight. And then we close it. We're getting better. Oof. So we can pretty much say for sure that weight has nothing to do with your IQ. Who would have thought? Alright, so let's do this again. Corel between IQ, comma, and height. IQ, height. Nope, same deal. Corel between IQ, I need to get better at this. Corel between IQ, and we want to put a comma, and we just did height, so now we're going to do exam 2, go away. Boom. Equals Corel between IQ, we put a comma, and then we want to do exam 1. Come on. Yeah. That should do it. What did I do? Can I just do E, all of E? Is that how it works? It is how it works. IQ, exam 1. Alright, and we're not going to run a correlation between subject ID, major, and gender, because those are categorical variables, and you can't run a correlation between a continuous variable like these guys are and this categorical variable like those are. Alright, so we did them all. That's not where I'm looking at my questions. My question is, what variable correlates the most with IQ? Alright, what's the biggest one of these? Ah, GPA. Boop. IQ and GPA have the highest correlation at R equals blah blah blah. Cool. Dunzo. Alright, what's the best predictor of exam 2 scores? Alright guys, predictor, that's just another way of saying correlation. So what's the best predictor of exam 2 scores? So I'm going to do the exact same thing. So equal Corel of exam 2, comma, exam 1. Nope. Exam 2 to exam 1 equals Corel exam 2 to height. To height equals Corel exam 2 to weight equals Corel exam 2 to height. Yeah. I did weight again. I'm a dummy. No, I'm a dummy. Just wait. So I want that to be I for IQ. And finally GPA. Exam 2, comma, GPA. Close it. Alright, so what's my highest? Ooh. You would think that exam 1 would be the best predictor of how they score on exam 2, and it is pretty good at a 0.85, but GPA just barely squeaks out the win. So what's the best predictor of exam 2 scores? Boom. Exam 2 and GPA have the highest correlation at R equals that guy. Cool. Alright. What's a better predictor of weight? Participant's height, major, or gender? Use a combination of interpretation of trends seen in bar plots. You can run a correlation. Yeah, we already talked about that. Alright. So what's the best predictor of weight? Height, major, or gender? Alright. Weight. We got weight. What's the best predictor? Weight, height, major, or gender. Alright, so we can find the correlation between weight and height. That's not a big deal. Have we done that yet? Let me go over here. Oops, I hate you sometimes. Correl between weight, comma, and height. 0.79, weight and height R equals that. And we can plot that too. Let's see how we can do this. I'm going to insert in, it's going to be a scatter plot. Where can I select my data? Yeah, I haven't really done this, but weight. Oh, okay. Alright, let me start over. Can I do like weight and height? Oh boy. Oh boy, that was so easy. Cool. So I just had to select those two and then insert in the graph, which is great. So in this graph we have, that looks like weight down here and height at the top. Weight by height. And if I wanted to, I could label these axes, which I should, but I'm not gonna. Come on. Alright, now, so we know that that's pretty good. What's gonna be better? This with a correlation of 0.8, pretty good. Look at that. If I wanted to draw a line representing the relationship, it'd be pretty much a straight line right through there. Major or gender? What's going to be a better predictor of height, major or gender? So I could make two more plots. So if I'm going to do, I guess I need to figure out the average height. What question am I asking? The average weight by major and gender. Alright, so that's going back to, let's sort by major because that's going to be the hard one first. Filter. Yeah. Boop, 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 boop. Weight. It's the average weight. 166.5. 166.5, that's the average weight for major 1, major 2, major 3, major 4, major 5. And we know that that is computer science, electrical engineering, psychology, physics, and then art. We're doing great. We're doing great, guys. Alright. That's major 1. Nope. Major 2. 172. Physics. 171. 1, 2, 3, 4, the fourth one. 166.97. I'm just going to say 167. I'm lazy. And then the last one is 178. Insert. It's a Mar chart. Oh. If I do it that way, insert. Ha ha ha. Gotcha. Okay. So it likes it when the label's on the left and the number's on the right. Okay. So boom, I just made the chart. Weight by major. Let's try to get these charts names, guys. So what do we got? We got 106 or 166 pounds all the way up to 180 pounds. Now remember how you can kind of exaggerate these differences. So if we were to look at, if we rescale this axis, format axis, if we say let's start at 0 and end at 200, that difference in these are pretty much gone away. Pretty much. All right. What about weight by gender? Gender. To filter just the ones. Weight 174. Is that what we're doing? Yeah. Weight by gender. Weight 174 for just the ones. Female 171. Male is 168. Bloop, 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 bloop. Oh, wow, that looks like a big difference. Wait, hold on. Let me format my axes to be the same as the other one. 0 to 200. Boom. Wow. Wow. Weight by gender. So it looks like it doesn't really matter what gender you are, you're still going to be somewhere around that area. It doesn't matter what major you are, you're still going to be somewhere around that area. But oh, come on. I wanted you. Whatever. But I can put, if I look at that graph, followed by this graph, I would say that weight has the best relationship with height out of these three variables. Weight, gender, height. I'm going to say height, because it has that super big R score and the plot looks so nice. Height would be the best predictor of weight from those three options. Then I'm gonna paste that in there. Come on, guys. How do I just copy? Let's clear all my filters. picture? Yeah, there we go. Cool. Alright, what's the z-score? Can we do z-score, guys? Well, I didn't even read the question. What's the z-score of subject 10's weight? Alright. Can I figure out the z-score of all of weights? Is there a z-score? Actually, I think it's called standardize. Can you standardize me? Are we still on weight? God, what's my obsession with weight? Okay. Too few arguments. Ooh. So it looks like standardize, we need whatever that x part is, the mean and the standard deviation. Right, because we can figure out the z-score just by doing that. If z-score formula. Yeah, right. So it's just the whatever the x value is minus the mean over the standard deviation. Boom. Yeah, okay. I mean, we could figure that out without even using that stupid thing. All right, get out of there. All right. So forgot already what we're doing. Weight. We want to find weights, mean and standard deviation. Weights. Mean is 171. Mean of weight is 171. SD of weight equals, what is it? Standard deviation of weight is 26.7. Alright. What's the question? What's the z-score of subject 10's weight? Subject 10, this guy, subject 10's weight was 111. So our x equals 111. Dang it, where was he? Subject 20's weight is... Subject 10's weight. God, I'm an idiot. 111.54. Yep. Okay. So if we're looking at this picture here, because I'm an idiot, can I paste a picture? I can. Great. So what is it? Our z-score equals our x, which is 111, minus our mean, which is 171, all over 26. Not really that great with Excel, but here we go. Boom. That's our z-score. That's weird. Okay. Cool. Done. Alright, what was subject 20's percentile rank on exam 2? We want to figure out percentile rank. Can we do that? Oh boy, percentile rank already exists. Alright, percentile rank of, what are we doing again? Exam 2. And then I'm guessing it's asking for our x. And what is our x? We are looking at subject 20, rank on exam 2. Subject 20, boom. Can I close it? Boom. That rank equals 73%. Excel's pretty great, guys. Alright, how tall is someone whose height is in the 80th percentile? Alright. How tall is someone? Alright, we're talking about height. I'm talking about, alright, equals percentile height. And what was the question? 80th percentile. So I've kind of done this before. 0.8 for the 80th percentile. 186 centimeters. Alright, what percent of the distribution falls between a score of 60 and 80 on exam 1? Alright, that was... I'm going to use my calculator because I liked it. So if I go to online stats resources, I like that guy. And this guy, this is the one that I like. Okay, so what was the question? What percent of the distribution falls between a score of 60 and 80 on exam 1? Alright, so there's two different ways I can go about this. I can calculate the z-scores and then look it up in the back of a z-table, or I can just figure out the mean and standard deviation of the whole distribution, plug that into these number boxes, and then move my x value around with my mouse to figure out what the percent of the curve is, and that's the one that I'm going to do. So, for exam 1, what's the mean and standard deviation for exam 1? Equals average of the whole dang thing, 51. Exam 1 mean equals that. How dare you? Just paste the value. Yeah, don't worry. There. Okay. Exam 1 standard deviation equals ST_dev of exam 1. 27. Did I just figure this out? That number is very familiar. Exam 1. I'm not going to worry about it for now. Maybe I'm an idiot. Maybe I did this all wrong. Who cares? So I got my mean and standard deviation. So I'm going to go ahead in my calculator and put those in. The mean was a 51, and the standard deviation is a 27.7. Let me just double check what percent of the distribution falls between the scores. Okay. So then I'm going to move my x value to 60. Alright, what is the shaded area? 62.7% is with below there. 62.7%, 62.7% for 60, and for a x value of 80, my x value is 80. Can't get any more. That's good enough. 85.8. 85.8. Now, can I just subtract those two guys together? Come on. Fine, fine. Have it your way. 85.8 minus 62.7. 23.1. 23.1% of the curve lies between the value of 60 and the value of 80. So I'm saying 23% of the whole distribution falls between right here and right here. Okay? Alright, and what is the percentage distribution of only psychology majors taller than 160? Alright, so we're looking at height, but only for psychology majors. So I'm going to filter. What's going on? I want to filter. Well, alright, I'm talking about height. height, filter. Nope, I'm not filtering height. Don't be an idiot. I'm filtering by major. And what are the major? What number is psychology? No. Sorry, guys. Psychology is number 3. So if I filter for just number 3s, what's their mean height? Their mean height is 173.5, which I've already figured out before, but whatever. This is mean of psychology people. What about the standard deviation of psychology people? Can I do this? Standard deviation equals standard dev of equal. Can I do this? And now I'm a little bit afraid. I'm gonna just double check standard deviation of plus that guy, plus that guy. I'm gonna select them individually. Just haha, that's my standard deviation. I think that calculates the standard deviation between all of them, which makes me question if my method of figuring out the average down there was the same, but whatever. Whatever. This is an example. I'm not grading myself. Alright, so that's our standard deviation. It is 19.74. So I'm going to go to my calculator. What was my mean? 173.5. And my standard deviation was 19.74. Yep. Alright, and what's the percent of the distribution of the psychology majors that are taller than 160? So if I move my x value to be around 160, what do we got? Alright, what is the white area? Because I'm talking about what's the percentage of the distribution that are taller than 160. So I'm going to look at that white area percentage, and that's 74.63%. 74.63%. And I'm done. Thank you.